This is the second part for that chapter 19, and we're going to look at the 6 main classes that exist for enzyme, and those depend on the kind of reaction that are catalyzed. So you need to be able to assign an enzyme to the correct class based on its reaction. So how do we name them? Most of them are going to have a name ending by ASE, exception papain and trypsin. Most of the time you have two parts. First, identify the substrate, the reactant on which the enzyme operates, and then you're going to name that enzyme that describes the reaction. So need to read what are oxidoreductase, what are transferase, what are hydrolase, what are isomerase, what are lyase, what are ligase, that are linking. Some example right there. Kind of reaction here, which one that catalyzes the following reaction? Well, you look at here, you identify the type of reaction, reading the chemical reaction and find what has changed. You see here you have an amino acid group and a carbonyl ketoxygen atom have been exchanged between the two molecules, making two different molecules. So in that case, you are going to be able to say they transfer an amino functional group, and the enzyme then needs to be a transferase. Looking at the specificity of enzyme, very important to look at the active site, and that is where you have the exact fitting to help the reaction to take place. So there are two models. One is a little bit controversial, but I still need to present both of them. One is called the lock and key. So you have only one key for a lock, and that means the substrate is described as fitting onto the active site as a key fits into a lock. Only when that can happen, the enzyme will be activated. The induced fit model, where the enzyme has a flexible shape, and when the active site is filled by the substrate, that will change the shape of the enzyme, so it's called induced fit, and then the enzyme will be operational. So for reaction to occur, the enzyme and substrate molecule must come together and form that enzyme-substrate complex.